I finally got my hands on a boxed ZX Spectrum Toastrack. I don't know if it works, we're going to have a look together, and if it doesn't work, we might have a repair video out of it. Let's have a look. So here it is in the original red box. Thrilled to finally get one of these in a box. These are really hard to find. Slightly miffed that I marked the box on the top opening the package. I blame myself 90% for that, and the person who packaged it up 10% for not wrapping it in bubble wrap. Anyway, still happy with it. It's a lovely example. I'm pretty certain this isn't a reproduction box, so I'm gonna call that a win. Anyway, let's have a look inside. We're interested in the hardware, the electronics, and we're going to fix this because I'm assuming it's not going to be working. Opening the box now, the flaps are all intact as well. Lovely, there's a bonus. And these polys inside hopefully don't have pen all over them and hopefully haven't been picked to pieces. Cross your fingers for me, please. Okay, we've brought it out upside down, but it looks okay. There's an imprint on the bottom there. Never mind. Let's flip it over, holding it together carefully so it doesn't all fall out. And there it is, Sinclair ZX Spectrum plus 128K. And it's not got ink all over it. It's a little bit grotty, but it's one of the better examples that I've seen. And we're inside now. There's a bunch of tapes crammed in here. I'm not sure what came in the original box, but I'm pretty sure it wasn't a random jumble of games, and it would have included a manual, which I've got a few of them, and a power supply, which I also have a few of them, so I should be able to make up a complete kit here. But what about the machine itself? I can already see some things going on with the power socket. We'll have a close look at that now. Otherwise, it seems to be fairly good nick. It needs a little bit of a cleanup, but all the keys are there. They're not too yellow, and there's no bits missing for that from what I can see externally. Looking at the underside of the case, it has both of its legs and 4 feet, and those feet are kind of hard to find and hard to replace. Looking at this barrel socket, yeah, somebody's replaced that with one that isn't the right kind and kind of bodged it in. I expect we're going to see some kind of dodgy patchwork inside the case. Alright, let me switch lenses, we're going to have a closer look at it. So here's our socket. It's been tacked in with one screw, which will have left a hole in the original case. Not to worry, we can put up with that. I'm going to replace it with a proper replacement. We've got screws missing left, right and centre, but I've got bags of them, so no worries there. If you're interested in serial numbers, this is A, I think, 108049136 in yellow. Okay, it's time to look inside. The top comes straight off because there's no screws in it, and we can pop these ribbon cables out. These ribbon cables come from the keyboard. It's a membrane. There are 2 of them. One on the right is wider than the one on the left. Ordinarily, they pop out very easily, but this one is hanging on in there for dear life. I was almost pulling the socket off the board trying to remove it. I did get it out in the end, and I'm definitely replacing that membrane anyway, so I'm not bothered that I tore it. Normally they won't be this stuck in. There it goes, finally. Now we can see the new socket and how it's been plumbed in, and they've used really long wires, and we'll remove them and we'll do it properly. I'm going to just take the voltage regulator off, which is this bit down here attached to the heatsink, straight away because I'll be getting the board straight out of that case. Before we do that, let's just get really up close and have a look at what's going on here. Here are 2 long cables, red and purple, and I can see that the original legs of the original DC barrel socket are still there. We'll be able to see this more clearly if I remove this, so let's get this screw out. And we can see, there we are, these wires have been soldered to the legs of the original DC barrel socket. We'll remove those legs as well when we pop a new one in. So let's remove those 2 wires and get the board out of the case. Starting out by clearing the solder from these 3 big joints, and we can easily remove those legs. and they've come out without too much fuss. I had also noticed that the sticker had come away from the EEPROM. The purpose of this sticker is to protect the innards of the EEPROM from UV light, which is how they are erased, which we don't want to happen. I'll get a new sticker on there in a bit. So where are my replacement DC sockets? Here they are. These will fit the Spectrum 48Ks and 128Ks. They don't work on the later ones where you got the DIN power sockets, obviously. Okay, we're looking miles better now, and we can start performing some tests. Before we get into that, let me take a second to say thank you to this video's sponsor, PCBWay. If you're in the market for a PCB prototyping service, or you're into your 3D printing projects, check out PCBWay. They're very reasonable and extremely easy to use. Even I can use them and I don't get too confused. I'm currently expecting a package containing a bunch of prototype boards for my new ZX Spectrum logic analyzer interface, which you can expect to see very soon in a video here. So go and check them out and see what they can do for you. Our first port of call is always the power circuit. So we should be getting plus 5 volts, which you can see in the top left of the schematic. That comes from the 7805 voltage regulator which was attached to the heatsink. We should also be getting plus 12 volts out of the power circuit, which you can see in the bottom right of this schematic. Now these voltage supplies go to various chips around this board, and what we're going to do is measure the resistance of that voltage supply to ground. The reason we do that is if any of these chips failed in a way which shorted the voltage supply to ground or to anything else, it could cause the board to draw way too much current, which would blow more components in our power circuit and basically cook everything. So this is a really good first check to do, and the 5 volt supply has a resistance of about 440 ohms to ground, and next we're going to check the plus 12 volt supply. And what we're getting from plus 12 volts to ground is about 1.5 kilo ohms. Neither of those readings was particularly close to zero, so I'm happy to apply power from a current limiting bench power supply. I'm just setting up the current limit to about 800 milliamps. I think some of these Toastracks will draw more than that, but let's just start low for now. We need to attach our 7805 5 volt voltage regulator to the board first. I've left that attached to the heatsink, but I've removed the heatsink from the case. Now we can plug it in and have a look at our current draw. And it's drawing 10 milliamps. That says to me there's either a bad connection to the voltage regulator or the voltage regulator is gone. So I'm just going to put in a new one and briefly plug it in, not leaving it plugged in because it's going to generate too much heat without a heatsink. And we're getting 700 milliamps, which is much more like it, so I think our voltage regulator is fried. On closer inspection, I noticed that the connector which goes into the voltage regulator is a little bit melted, so something's failed here in a fairly spectacular way. For now, I'm going to keep using it because the connection still seems to be alright, and I'll keep an eye out for where I can get a replacement. There's our new voltage regulator in place. We're going to plug it in, power up, and I'm going to have a quick look if we're getting any video signal out. I'm using an RGB cable to SCART through a HDMI video capture device. Unfortunately, we're just getting a black screen out, and we're going to figure this one out, but anyone who's familiar with the Toastrack is probably shouting the solution at me already. One thing that I did notice was when I unplugged and plugged in the video cable, I got a flash of the menu. I can pause it here. We can see that the Toastrack is pretty much working. There's just a problem with the video circuitry. I thought I would probe each of the pins on the RGB socket. So here it is, it's this 8-pin DIN socket, and we need to identify which pin is which on the underside of the board so we can see what's going on. Now that I'm editing this video together and narrating, I've noticed that it tells you on the schematic which pin is which on the solder side. You see at the top there in the square box. Oh well, I learned something today. Let's get on with the video and you can watch me figure this out for myself. After a little bit of probing around and checking against the schematic, I managed to identify pins 1 to 8 on the underside of the board here, scribbled them on MS Paint like this, and then I was able to probe and see what the signals looked like. So let's have a look. Starting with pin 1, this should look like a composite video signal, and if you're not familiar with what that looks like, it doesn't look like this. The amplitude should be greater than 0, which we're seeing here. It's trying to do something, but it's obviously not working correctly. Okay, what about pin 3? This is our bright signal, and I'm expecting something that looks a bit more like a square wave. Here we go. Yeah, that's a square wave. Ignore the max voltage there, it should be multiplied by 10. I've got the oscilloscope set up wrong. Anyway, I went round all the other pins and they all looked like square waves, which looked pretty promising. My attention was definitely on pin 1, which is that composite video signal. Seems to be indicating to us a problem with the board. I will add that the lack of a composite video signal isn't necessarily what's causing us to have a black screen. It probably isn't, but it's telling us that something's wrong and is giving us somewhere to look. So back to the schematic, and pin 1, let's trace it up. It goes through R134, ZTX313 transistor at TR14, and the collector of that transistor is connected almost directly to 12 volts, which makes me think, I didn't check the voltages, did I? That should have been the next thing I did after plugging it in, and I got carried away. Sorry about that. Okay, let's roll right back and we'll check our voltages, see if we have 5 volts and 12 volts. Okay, we're plugging in. I'm going to measure the voltage directly on the right hand pin of the regulator. Should be 5 volts. 5.056. Good enough. Okay, what about 12 volts? We should be getting 12. We're getting 1.4 volts. Alright, I would have picked that up a lot earlier if I hadn't gone on and started messing around with video signals. That's okay, we're going to turn our attention to the power circuit then. We know that 5 volts is working, that's coming in on the top left there next to C74. What's missing is plus 12 volts down in the bottom right. The ZX Spectrum power circuit generates 12 volts using a charge pump oscillator. I'm not going to explain this in detail because I wouldn't do it justice, but essentially by charging and discharging capacitors we can generate a higher DC voltage than the voltage we started with. That's how we get 12 volts out of our input voltages. What this means is if we probe around the middle of this circuit, say on the collector of TR4, we should see an oscillating voltage which is then regulated to produce a flat 12 volts. So we're going to do that and we're hoping to see an oscillation which goes higher than 12 volts. Let's see what we get. So here I am probing on the collector of TR4 and what we have is a flat 8.56 volts. There's no oscillation happening at all. So this is a fairly typical failure mode, I would say, and it generally means that TR4 has gone bad. I'm going to remove TR4 and TR5 and test both of them and probably just replace both of them anyway with new ones. So the ZTX650 is an NPN transistor, and if I put the positive probe on the base and the negative probe on the emitter on diode test mode, we should see some voltage drop, and we're seeing nothing there, 0L. Okay, let's do that same test on a new one, which I assume is good. This is a ZTX651, a drop-in replacement. Positive probe on the base and negative on the emitter, and we see we get a voltage drop of 0.649 volts. That tells me that our ZTX650, our TR4, is kaput. Let's check out TR5, that's a ZTX213. Flipping the probes because it's a PNP transistor, trying not to ping it away across the desk. A negative probe on the base, positive on the emitter, we're getting a voltage drop of 0.699. And let's check on the replacement and we get 0.644. Okay. Let's continue testing. We can try checking from collector to base, and on the old transistor 0.693, and on the new transistor 0.644 again. Okay, let's try flipping the probes now, and we shouldn't get any reading here with positive on the base between either the emitter and the collector, and we don't. And that's the same for the new transistor. It's looking so far like our ZTX213, our original TR5, is actually okay. Well, I'm going to replace it anyway since I've already removed it. I'm going to pop in a ZTX 751, which is a drop-in replacement, the one you can see here on the right. When I hooked everything back up, the bench power supply started limiting the current, so I just turned it up a little bit to 900 milliamps and everything was back to normal. We were up and running, and let's do a quick check of our voltages. Fingers crossed, we should be getting 12 volts here, thereabouts, and 12.46 will do. Lovely. I want to probe the collector of TR4 again and show you this oscillation. Remember, we had a flat line of 9 volts previously. Now we can see we have this lovely oscillation between around about 0 and 19 volts ish. And you can imagine with a bit of smoothing and regulation you could get 12 volts out of that. And while we're at it, let's probe pin 1 of the RGB connector. This is a composite video signal. This is recovered now that we have 12 volts back. Let's just zoom in, we can have a look. The dip in the voltage is setting up levels and a bit of horizontal blanking. Where the voltage remains high and then oscillates, that's our pixel data coming in, 1 pixel at a time, which I think is quite nifty. Anyway, let's see if our RGB video signal is working. And it is, check it out, there's our menu. And that's also good news that the Specky seems to be able to boot to the menu. We can see jail bars there, vertical jail bars. We'll fix that with a mod. But first things first, let's run a diagnostic ROM and see that our memory is all working. I'm using a Dandanator which arrived with Brendan Alford's diagnostic ROM built in. Does mean I need to press R and then S to trigger it, so I'm using a little donor keyboard here with a membrane that works. And let's see what it does. I've sped this up quite a lot, but it's tested the lower 16K of RAM which passed, tested the ROM and that passed. Now it's testing all of the RAM banks. Jumping ahead, and we see that passes too. RAM paging passes as well. Not rampaging, paging of the RAM passes. And then it will just cycle that process ad infinitum. So we don't need to do that just yet. We need to do a couple of mods, so let's get on with that. First thing I'm going to do is the jailbar mod, or the anti-jailbar mod. That involves replacing C7, C8 and C28 with capacitors of different values, and that's going to fix, or at least improve, our vertical jail bars that we saw while we were running the diagnostic ROM. Here's a little interesting tidbit of information. If you are using the composite video out of this machine, which is very rare, most people don't do that, it's quite hard to do compared to a normal 48K Specky, this mod will make the jail bars worse on the composite video signal. At least that's what I saw on one of the machines that I was working on. We're also going to replace R115 with a different value resistor, and what that's going to do is balance the volume of the two sound sources on here, which is the beeper and the AY chip. It's just going to make our games that use both of those sounds a little bit more in balance. So let's have another look at our diagnostic ROM and see if we've not bugged anything up, and see if we've fixed these jail bars. Just for comparison, here's what it used to look like. And here's how it looks after the jailbar mod. They haven't completely disappeared, but it's a big improvement. Now it's time to get the keyboard working. But first, let's go completely off topic. I just had a build around who was attaching some straps to a wall, and he managed to crush the mains electric cable in the garage, which shorted the earth without even cutting anything. It just crushed it, and that was enough to short it out and blow the fuse, which I thought was quite interesting. Anyway, I fixed it now. Let's go on with this keyboard. I want to have a quick look under the return key just to see how mucky it is, and it doesn't look too bad, which is nice because I'm not going to bother taking this all the way to bits and cleaning every key. We do, however, need to remove all of these screws from the keyboard backplate in order to remove the keyboard membrane and put a new one in. That includes the two clamps, there's one for each ribbon. With them removed, I can dig out a new ribbon. And there it is, in place, not much to say here, just reattach the back plate and the 2 clamps. Done. I'm a little bit suspicious of the keyboard ribbon connectors. They're mounted in a way which isn't flush to the board, I don't really like that, and I had to really writhe on that to get the old keyboard ribbon out, so I'm going to replace them anyway just to be safe. I also want to clean the edge connector, but my fiberglass pen ran out and I'm waiting for a new one, so I'll do that later. Let's reassemble a little bit, test the keyboard and then finish up. So I'm putting the heatsink back on and plugging in the voltage regulator. I'm going to plug in our new keyboard and let's give it a quick test. I've ran through the diagnostic ROM keyboard test, but I wanted to try typing as well because I'm never sure if the speech marks are working correctly on these plus cases because they kind of press 2 buttons at once. And yeah, you do have to kind of press a little bit hard, that's just because of the bubble mat I think and the plastic backplate. Don't mind about that, I'm happy with it, and I'm going to have a little go playing a game because I'm getting carried away and distracted from the task at hand. There's Dizzy and I can control him, lovely. All that remains then is to replace the stilts which the top of the keyboard sits on. I've got a couple of them spare, and find some screws to go in. You may notice I haven't changed the capacitors. The reason I haven't done that is it's working and I'm not selling this or anything, it's staying in the collection, so I'm going to keep it original. There are a couple of other mods I also haven't done, such as the Unrainer mod. That mod involves replacing a chip, and that's only necessary if you want to play the games which are affected by the rain effect bug, so I'm not too bothered about that either. And the other bits and bobs you can do to these things I may or may not do as and when I feel like it. So it's back into the original red box for this, until the future when I might want to play on it or do some of those extra mods. Thanks very much for watching everybody, I hope that was interesting. I'll catch you in the next one.